Hey everyone, so today we are going to continue with rectilinear motion. Remember, we've talked about this a couple times. We hit it a few different times throughout the year. So that's the idea of position, velocity, and acceleration and their relationship. Alright, so I want you to pause the video and try this practice AP problem. So we are finding the local minimum. So g prime equals 5x to the fourth plus 3x squared minus 2. G prime equals, we can factor that, 5x squared, x squared, let's see, plus 1 minus 2. So then when we set that equal to 0, so there's no solution there, and then here we get x squared equals 2/5, square root of both sides, plus or minus. So notice that we have to rationalize the denominator, so we're going to multiply top and bottom by 5, so we get plus or minus root 10 over 5, so it's either A or B, we have to figure that out. Now you have an option. If you want to plug into the second derivative, use the second derivative test. I think I just made my regular number line and did the first derivative test. I think in this case it's easier. So if I plug in like 10, right, I'm plugging into here the first derivative, that would be a positive and a positive. Plug in 0, that gives me a negative and a positive, and then negative 10. So local min would be positive root 10 over 5, so the answer is B. Okay, so we're going to write down a bunch of vocabulary. If you were taking Yukon Physics, you probably know this, but not everyone is in that class. So, initially, what it initially means, t equals 0, right? Find the position initially. So what's the position when t equals 0? At rest. When I'm at rest, I'm lying in bed and I'm not moving. My velocity is 0. At the origin is a position. X of t equals 0, or whatever they name it. Sometimes they name it S of t. It goes back and forth. The particle is moving right. So moving, that's velocity. To the right means it's greater than 0. Sometimes it's up also. So the particle is moving up, the velocity is greater than 0. And then moving left, that means the velocity is less than 0. And that's also down. Average velocity, and notice given position, this is important. Remember that word average is typically slope. So this would be like your x of b minus x of a over b minus a. It's the same thing as the average rate of change, okay? Average velocity is average rate of change. Instantaneous velocity would be the velocity at some point, say x, v of x. We're plugging something into velocity, v of 4, v of 3, v of 100, whatever. Velocity is increasing. So velocity increasing, remember this is slope. Slope is positive. So this is v prime of t is greater than 0, or that means that the acceleration is greater than 0. So velocity is increasing when it's increasing means derivative is positive. So the derivative of velocity is positive, and then decreasing derivative is less than 0, or the acceleration is less than 0. And then finally, speed. Speed is velocity without direction. So it's the absolute value. Right? So that's your vocab. All right, so now let's go through and do a few problems. So here they're giving you your position is S of t. And we're always going to deal with positive t. Like, we're not going back in time, right? No no time machine or anything. So if you get a negative, you can just ignore it. Determine the time intervals when the particle is moving to the right. So the particle is moving to the right. That means the velocity is greater than 0, right? The velocity is greater than 0. And it's helpful to write that down. So if position is s of t, velocity is the derivative. 3t squared minus 18t plus 15. Factor and solve. So I'm going to pull out that 3. T squared minus 6t plus 5. That's t minus 1, t minus 5. So this process is exactly the same as finding your relative max and mins, right? So we have 1 and 5. So if I plug in something to the right of 5, that's, say, 6, that's a positive. I plug in 3. If I plug in 3, that would be a positive times a negative. And a half, right? Or you can always plug in 0 also. That's also positive. But remember, we always have to be greater than 0, and it tells us that in the problem. So moving to the right, that's where velocity is positive, so 0 to 1, and then 5 to infinity. Moving to the left, 1 to 5. When does the particle reverse direction? Well, that's just at our critical numbers. T equals 1 and t equals 5, right? Before t equals 1, we're moving to the right, then we move left, then we move right again. When would a particle be speeding up or slowing down? So I really wish we were in class right now because I don't have I have like a very physical way of doing this. So speeding up, remember about position. So if velocity, here's my velocity, is moving to the right, and then, so it's a point and it's going this way, right? And then the acceleration is also going that way. Imagine the acceleration is like pushing on this point and making it go faster, right? Acceleration is when I slam my foot on the gas on the highway to go faster and faster. So this acceleration is pushing it to go faster and faster to the right. But because we're talking speed, we could also be going this way, right? If this is my velocity and my acceleration is also going that way, we think of it as slowing down, but we're not. We're just going in the negative direction, so it's pushing it, pushing it, pushing it. So a particle is speeding up when both the velocity and acceleration are the same sign. Versus if my velocity here is going to the right, but my acceleration is going to the left. It's like, imagine I'm trying to run this way, right? And then, but someone's got me by the arm, and that's usually what I have. Someone has, my acceleration has me, and they're pulling me. I'm still moving to the right, but there's a force preventing me from going faster. And then the opposite could be true also, where my velocity is going to the left, but my acceleration is going to the right. So when the acceleration and velocity are going in opposite directions, that acceleration is like slowing down my velocity. So v of t and a of t are opposite signs. All right. If the position of an ant traveling along a horizontal path time t is 3t squared plus 1, so this is the position, x of t. What is the ant's average velocity? Remember, velocity is slope, average rate of change. This is f of b minus f of a over b minus a. So x of 6 minus x of 1 over 6 minus 1. Whenever you see that word average, it's typically slope. So we're going to plug into 3t squared plus 1. So let's see. 3 times 36 plus 1, that's 108, 109. So we get 109 minus, when I plug in 1, I get 4. It's 105 over 5, which is 21. D. All right? So again, average velocity is average rate of change. It's just another, and we're given the position. Now, if we were given the velocity, that's a totally different problem. What's the average velocity when you're given the velocity? And we'll go over that later in the year. All right, pause the video and try this one on your own. A bottle rocket is shot upwards from a 10-foot stand with a velocity. After 3 seconds, the rocket is, let's see, we've got falling, rising. So let's see. Falling would be velocity is less than 0. Rising would be the velocity is positive, right? That's falling and rising are another words for up and down. So let's find v of 3. So v of 3 is 50 minus 1.6 times 3. 50 minus, what's that, 4.8? So that's greater than 0. So I know that because that's greater than 0, the rocket is rising. So I can cross off A and D. Now, is it rising at an increasing rate or decreasing, right? Increasing, decreasing, or a constant for E. So that's looking at what's the derivative, right? So what's the derivative of the velocity? Negative 1.6. So do you think, now here's the question. Is it decreasing rate or is it constant rate? It's not increasing because it's negative and it's a number. Now, is that a constant or is that decreasing? That is decreasing. The velocity is less than 0 at 3. Now, if you had 0, then it would be constant, right? If we had v prime equals 0, that would be a constant rate. All right, last one. We're actually going to cross off B, though, because we haven't learned that yet. That was on your performance task. All right, so find the acceleration. 1 over pi is a constant. That's just a number. Derivative of sine of 3t is 3 cosine of 3t. At t equals pi over 4 is the object speeding up or slowing down. Now think back, what did we say about speeding up and slowing down? We want to know, we need velocity and acceleration. Are they the same sign or different signs? So pause and do that. So v of pi over 4, velocity, is 1 over pi plus sine of 3 pi over 4. All right, so sine of 3 pi over 4, that is quadrant 2. Sine is positive in quadrant 2, so that is greater than 0. And then the acceleration of pi over 4 is 3 cosine 3 pi over 4. That's less than 0. So this is slowing down because velocity and acceleration are different signs at pi over 4. Slowing down because v of pi over 4 and a of pi over 4 are different signs or opposite signs. On the interval pi over 2 to pi, what is the velocity when the acceleration is 3? All right, I want you to pause and try that on your own. What is the velocity? So that's our final thing we need to find. But it's telling me when my acceleration is 3. So when's my acceleration 3? So when is 3 cosine of 3t equal to 3? Well, let's see. 3 cosine of 3t equals 1. Cosine is 1 at 0 and 2 pi, right? So 0 equals 3t. 2 pi equals 3t. But we need to be between pi over 2 and pi, so it's not this one. So t equals 2 pi over 3. So I found when the acceleration is 3, now what is the velocity? So the velocity at 2 pi over 3 is 1 over pi plus sine of, let's see, 3t. So the 3's cancel, 2 pi. Sine of 2 pi is 0, so we get 1 over pi as our answer. So these are, I don't really think these are difficult. It's really the vocab that's difficult. So really read the problem and think about what it's asking you. All right, that's it. Have a great day.